Good afternoon, everyone. Welcome to the web-based decision support system course for decision makers and academicians. Today, we'll continue our discussions on the database component of the decision support system. We have seen four major aspects of the decision support system. So, if you think about it, we were talking about DSS, which had four major components: DBMS, the database management system, then KBMS, the knowledge base management system, then UIMS, the user interface management system, and then what we did the last was MBMS, the model based management system. And we have seen all the four in brief, and this we are seeing in depth now. Okay, we are looking into this component of the decision support system, right? So, in this aspect we have already seen what are the three layer architecture we have seen: the view definition language, storage definition language, then the data manipulation language, data definition language, etc. We have seen that aspect as well, and we have also seen the what's a query language, etc. that we have already talked about. And then now we are in the process of the conceptual design. Okay, that's what we are trying to do today, is how do we do the conceptual design of the database, and that for that we need what we call as the entity relationship. Okay, and from there we translate to what we call as an ER diagram as part of it. Okay. So, without further delay, let us look at the main terms that we need to understand today and to go from there. So, the first word that we hear about is database application. Again, okay, this is with respect to DSS. Okay, we are talking about corporate or business DSS. So, the database application is, okay, in the simplest terms, it is a specific database plus application programs, program, okay, that implements or that implement the database queries and updates. Queries and updates. Okay. In this course, so it is a specific database, some specific database. It can be like an inventory database, it could be something, and then an application program that implements the queries and updates of the database. Okay. For this course, okay, we are going to look into MySQL, or what we better known as MariaDB. Okay, is the RDBMS, okay, the relational database management system that will actually store the database or allow us to create and store the database. And we will also look at what we call as PHP. Okay, it's a language that actually allows us to create dynamic hypertext pages or dynamic HTML. Okay, so this is the application program. Okay. So, the retrieval of the data, the updation, representation of the results, etc., all of this will be done with the help of PHP. You can use other language like Python and other kind of things, but for the purpose of this course we will be dealing with PHP as such. Then comes what we call as second one, called the entity relationship model, ER model. Okay, the popular high level conceptual data model. Okay, we already seen what's a conceptual model. Okay, and it's a high level conceptual data model. We will use this. Okay, because it's extensively used by DSS designers. It's very popular. Okay, and allows the design of complicated systems. Okay, and its third aspect is easy to use. Okay. You can even do it with a pen and paper. You can use softwares like UML and other kind of things, but with just a pen and a paper also you can use this ER model. Okay. So, it is a high level conceptual data model. It allows us for the conceptual design, but more importantly lot of the DSS designers uses this, and it can help you to design complex systems or complicated systems, and it is very easy because all you need to do is to have a pen and a paper. You can have dedicated softwares like UML, Argo UML, etc., but then this is easy. Okay. Then comes what we call as the ER diagram. Okay. So, ER model is what we talk about. Then what is ER diagram? In a very simple way, it is the pictorial representation of the ER model. Okay. So, the entity relationship model for us in this class, we will be pretty much representing use instead of going through the extensive writing or other things, we will be using pen and paper to draw the ER diagram. Okay. So, that will become that is a pictorial representation of the ER model, right. Then the last what we also want to discuss here is the data requirements. Okay. And when people say a lot of these things about, for us in this course, data requirements means it is a concisely written, set of users requirements. Okay. So, when the user requirements are given to you, and lot of the time what happens is the rule is like this: the data requirements, okay, identify entities, then identify relations, then create ER diagram. Okay. So, that is how we go. So, the ER diagram is the pictorial representation of the ER model. The entities and relations, what we will see what they are, the definitions are, and the data requirements are the concisely written statements of the user requirements. Okay. Hopefully, you understand this part now. So, now let us talk about what we call as an entity. Okay. When we talk about the big term entity, what does it actually mean? Okay. The simplest term or simplest way to think about entity is it is the basic object of the ER model. So, another part of it is, okay, usually it is a thing, okay, it is a thing in the real world. Okay, that has an independent existence. That has an independent existence. Okay. So, what we are saying is that it is a thing, it is usually something that you can recognize. Okay. It is a, so this means a recognizable object, concept, item, etc. Okay. It does not have to be a tree, it does not have to be a car or something. It can be also something like a project which is on a piece of paper and has money and finances and resources associated with it, but there is, you cannot really, like you point a tree and say this is a mango tree, this way you cannot really point to and say that this is a project. The project exists on a piece of paper, but you can recognize a particular project by a project number or stuff like that. Okay. So, that is the entity. Okay. So, what is entity? Okay. Then second one is each entity has attributes. Okay. That's the second aspect of it. Okay. Each entity has attributes. What are attributes? Okay. They are particular properties that describes the entity. So, for an example, let us take an example as an entity, student of IIT Kanpur. Okay. So, that student has it can be a male, female, there is a physical, it can point to a particular student. Okay. So, there is a physical existence. So, it is a thing in the real world, it has an independent existence of its own. So, what are some of the attributes of the student? Okay. So, let us take student attributes. Okay. Some of the attributes will be the roll number of the student, that will be the easiest thing for us to identify because the roll number will be unique. Then there is the first name of the student. The student may or may not have a middle name. There is a last name, date of birth, address, academic program, etc. Okay. So, you can say that the roll number is, let us say 1 1 2 3 4 something like this. First name is Ram, then middle name is Kumar, then last name is Ram Kumar Krishna or something like that. Okay. And the date of birth is 1/1/1985 or something like this, and our address, etc. So, these are all attributes. Okay. The roll number, the first name, last name, middle name, they are all attributes of the particular student because it describes that student, whoever is called Ram Kumar Krishna, whatever we just came up with the name. Okay. So, that is the attributes. Then there are many types of attributes. Okay. So, many of them are there, and some of the important ones we are going to discuss now. Okay. Simple attribute. Okay. It is also known as atomic attribute. Okay. Versus composite attribute. Okay. This is also known as subdivisible. Okay. So, when you have a name, okay, when you say the name is Ram Kumar Krishna, okay, this is a composite because you can subdivide this into Ram, Kumar and Krishna. So, this is your first name, middle name, last name. So, now these ones, these three, they are atomic attributes. Okay. They are atomic because you cannot further subdivide this. Similarly, address is an example. So, if you say the address of the student is hall 3 IIT Kanpur, so then that can be subdivided into its components. So, atomic is the simple, you cannot further divide it, subdivide it, whereas composite attributes means you can further subdivide it. Okay. So, that is based on how granular the attribute is. Okay. So, some people call this as the granularity of the attribute as well. Okay. Then there is something, second one, the major one is called as the single valued. Okay. Single valued attribute. Okay. Remember, single for a particular entity. Okay. Single valued, it is a single for a particular entity versus multi valued. Okay. So, the example of the single valued versus multi valued is, let us say the program, okay, the academic program. Okay. Student is taking, let us say, is in a BTech, okay, civil engineering. Okay. This you can divide it into, this is subdivisible, it is into the program and this is the stream or department, whatever you want to call it, right. So, you can subdivide this, okay. But a student can also have a minor in computer science, right. So, you can also have a M.Tech computer science. This becomes what you call as a dual degree student. Okay. So, now the degree academic program can have multiple values depending upon the current status of the student. Okay. So, that is another example. Also, you can have something like address can have multi-valued attributes of the residential address, permanent address, etc. Okay. So, that is the other aspect. Okay. Hopefully, I think that is clear with you guys. Then comes the third one, which is called as stored versus derived. Okay. So, the simple example of it is, let us say somebody's date of birth. Okay. So, let us call the date of birth as 1/1/1980. Okay. So, this is a stored attribute. Okay. So, then the age of the person, okay, as of 1/1/2023, okay, that will be how much age will be 90,000. So, about 40, right, 40 years, that will be the derived attribute. Okay. It is derived from the stored attribute, okay. And derived attribute. So, that is why you rarely store the age of an individual in a database, because age is dependent on the time. You actually store the date of birth, and then the age is derived from the date of birth. Okay. So, this is the, I hope you guys have now clearly understood the entity, and it is a basic object, it is a real world thing with an independent existence, and each entity has an attribute, and attributes are particular characters or features or values that describe the entity, and then there are different type of attributes. We have already discussed the type of attributes at this point. Okay. Then we talk about what we call as null values, okay, and this is important because many a times null values are something that is very important in the database. Okay. For a simplest way of defining, okay, null values for us specific cases where a particular entity may not have an applicable value for an attribute. Okay. So, like for example, if you have in a database, okay, you have, okay, first name, middle name, last name. Let us say these are the three aspects there, three things that you are storing, and if my name has to be stored, then I have a first name I can write, I have a last name I can write that as well, but I do not have a middle name. So, the middle name is not applicable to me. Okay. So, I would typically put a null here. Okay. That means this middle name, because I do not have a middle name, so it is not applicable to me. So, such kind of a case, okay, this is known as not applicable cases, not applicable concept. Okay. So, that is one example of a null value when it is used. Then certain other cases where the value of a particular attribute might not be known or missing. Okay. So, you may have a scenario where you may not know or the value is actually missing. Okay. This scenario is known as unknown cases. Okay. So, unknown is different from not applicable, because not applicable is their value might be there, you may not know. So, somebody ask for my date of birth or something, and if you do not know, then that null means there is a date of birth, but you do not know about it, or so that is unknown to you, right. So, null can either describe not applicable or unknown. Okay. Then to handle both unknown and not applicable cases, null value is used. Okay. So, whenever you see null in a database, it is either unknown or it is not applicable. Okay. What it is, you do not know. So, you have to figure that out. Okay. So, remember that. There is another one that I want to add here, which I forgot to mention in the previous case. The simple single valued stored and other things. So, there is, I want to add another stuff called as the complex attribute. Okay. And complex attribute is like, okay, these are created by nesting a group of components. Okay. So, if when I have if you like, let us take an example. Okay. Take my address. Okay. So, we will say room number 219 IME building. Okay. Department of IME IIT Kanpur 208016 UP, etc. Right. So, this whole thing, okay, whatever you see here, what I just wrote here is a complex attribute, because you can break this down into, okay, room, apartment number. Okay. This is one thing you can do, and then building. Okay. So, that is another one. Then department, okay, you can have another one, landmark, you can have another one, city, state, pin code, then you have country, okay, continent, you can add whatever you want, right. So, all of these things put together, okay, nesting them together, combining them together, you can create an address attribute or address attribute one person. That type of an attribute is called as a complex attribute. Okay. So, this is a complex attribute. I can now create the address, a residential address also, and I say for address I have a official address and a residential address, then that two addresses, two complex multi-valued attributes can be created out of it. Okay. So, now let us talk about what we call as attributes. We have been talking about major type of attributes as part of this. So, now let us talk about what we call as the key attributes. Okay. So, so far we have discussed in attributes, we have discussed atomic attributes, right, and we have also discussed what we call as complex attributes, we have discussed multi-valued attributes. Okay. We have also discussed what else, what are the other things we discussed? We discussed composite and etc. Composite, we also discussed null as well. Okay. So, many things we have discussed so far and we see what it is. Okay. Now, let us talk about what is a key attribute. Okay. What is this concept called key attribute? So, an entity type, an entity usually has an attribute. attribute whose values are distinct for each individual entity. Okay. Let us call an entity type. Okay. Usually has an attribute whose values are distinct for each entity, okay, in the entity set. Okay. So, let us call the entity type as citizens of India. Okay. So, if the entity type is citizens of India, then there are so many attributes, and there are multiple attributes like they have name, they have date of birth, they have an address, okay, there is a PAN number, and then there is a Aadhaar number, etc. Right. So, let us assume that in this case the name could be same. Okay. Some people may have, there may be multiple people with the name Ayush, Akash, all those kind of things you can find. There is so many people with the same name. There are many of them, they will have the same date of birth also, and some of them will have the same address as well. Whereas a PAN number, not everyone have it. Okay. So, let us say it is only for tax paying people, only for taxpayers, but is distinct. Okay. We can use the word distinct, or we can also call it as unique as well. Okay. Not everybody may not have. Okay. Let us assume that Aadhaar number is for everyone. Okay. Everyone has it. Okay. Also distinct or unique. Okay. So, for a, if you are dealing with a scenario where you are only looking at the taxpayers, then Aadhaar number is a good key attribute. Okay. Because it can uniquely identify every taxpayer, no two Aadhaar number will be the same. Whereas, if you are looking at the entire citizens of, so one of the class we can think about is citizens of India, for which Aadhaar number could be the key attribute. Whereas, if you take another one as taxpayers of India, then PAN card would be another attribute. So, this is entity type 1, okay, and this is entity type 2, two different types of entity. Okay. Taxpayers of India is a smaller subset, they are also citizens of India, they will also have Aadhaar card, but they will definitely have a PAN card. The citizens of India is a larger set, not everybody is a taxpayer. So, whoever is not a taxpayer, they may not have a PAN card. So, Aadhaar card will become a much better key attribute. Okay. So, such distinct or unique attribute is known as key attribute. Okay. So, when somebody says I am talking about a key attribute, then that is this, we are talking about the unique. So, when in the database you will hear the term primary key, foreign key, etc., we are talking about a distinct or a unique attribute of the entity that can be used to uniquely identify that. Okay. Other thing also you need to remember is that certain entities can have more than one key attribute. Okay. So, if you add another attribute called the ration card number or something, then that could be another, or voter's ID card is another one. Okay. So, these are all different key attributes, that means they are distinct for each individual entity in that set. So, when you take these people, all the people of the citizens of, or the citizens of India, there are so many people in that entity set. Citizens of India is an entity type. So, individual citizen Ram, Sita, Geeta, they are all citizens, and their Aadhaar card or their voter's ID card, they are all key attributes because they are distinct or unique for each other. Okay. All right. So, now the question is, if an entity can have more than one key attribute, so what does this entails to? Okay. May result in the designer to choose a specific attribute from key attributes. So, this may force you to say, okay, I have so many key attributes, so which one will I choose? And you may have to end up choosing one, right? And we need to know what that it is. Okay. Then certain entities also may have no key attribute. Okay. So, certain it is possible. Okay. No key attribute. Such entities are called as weak entity types. Okay. So, like a person who we take the citizens of India and we define the people of citizens of India or people of India are people who are living within the boundary of the country, and we collect everybody's name, and between we find one guy who has come from Pakistan to India without any Aadhaar card or anything of the sort, then that person would not have a key attribute which is Aadhaar card we have designed, because there is the value for that is null, there is no Aadhaar card for that individual. I am not talking about a fake Aadhaar card, I am talking about a proper Aadhaar card. So, if that happens, then what that entity, that particular individual will be a the terrorist that crossed into India will be a weak entity type in that regard. So, I am just talking to you in real sense or real terms, so that you can understand or you can identify you can physically correlate what is an entity, what is an attribute and what is a key attribute, or when does an attribute becomes a key attribute and when does an entity becomes a weak entity, whether it depends on whether it has or does not have a key attribute. Okay. Now, what we do is, before we go forward, we will take a small break here, and then we will talk about the components of the ER diagram. And so, ER diagram is the entity relationship. So, entity and its attributes, how do you what are the conventions that you use to draw the diagram and etc. we will discuss in the coming lecture, and we will take a small data requirement statement from the customer, and from there we will draw a ER diagram also. And once that it is completed, we will go to the other topics of how to design and SQL and aspects of it. Okay. Thank you very much.